It's that time of year again, and I'm not talking about just the holiday season. It's the time of year when the United Nations convenes the annual climate conference. This is called COP. This year's COP 28 from November 30th until December 12th are the dates that it's being held, and this year it's being held in Dubai. Let me just share with you a couple of the stated goals. There are others, but among the stated goals of this conference, number one, they want to fight against climate change. I think it's interesting how everything is positioned as a battle. You know, we've got our war on drugs, our war on poverty, we've got a war on climate change. I want to talk about this in just a few minutes. They want, number two, to bring a significant reduction in CO2 emissions. This is predicated on the belief that carbon dioxide is bad for us, that it's bad for our planet. Science doesn't support that, and I'm going to talk to you about that as well in this video and where that information is coming from. Number three, phasing out of fossil fuels. You know, we all want to see new forms of energy, and I want to talk to you about this as well. We've had new forms of energy for over 70 years. If we were serious about climate, if we were serious about fossil fuels, we've had 70 years to bring those forms of energy online to revolutionize and free humankind from the shackles and the burdens of the industries that have held us under their thumb for so long. So I want to be really clear. I want to talk to you about that as well. And to limit the global temperature rise to 1.5 degrees Celsius from what is considered to be pre-industrial levels. I'm going to talk to you about this. The reason I wanted to share this with you is because this year's climate summit got off to a very unexpected start. It's being held, as I mentioned, in Dubai. The person that was chosen to head up this summit began with an opening keynote presentation and opening remarks that have shocked the world that is trying to fight against this climate battle, or fight this climate battle as it's being touted. I'm hesitating because I don't want to get too deep into the conversation before I share the information with you. So I want to read to you a single sentence from the opening remark. This is from Sultan Al-Jaber, is who it is that's heading this up. He is an engineer, so he is a scientist. Listen to what he says. Now, keep in mind, the last goal that I just shared is to limit the temperature rise to 1.5 degrees. Listen to what the keynote speaker is saying. This is a quote. Quote, "There is no science out there or no scenario out there that says the phase out of fossil fuels is what's going to achieve 1.5, end of quote." So what he's saying is that the changes that are being proposed to accommodate or to accomplish this 1.5 degree limit may not be worth the cost, the price that humankind is being asked to pay to accomplish this goal, when the science doesn't support that this goal is going to be accomplished by limiting those fossil fuels. Now, I want you to think about why this is important. This is the end of 2023. We're coming into an election year, 2024. Climate change is certainly a big part of the election dialogue, and there is all kinds of hysteria that is being touted across social media, the World Wide Web. Of course, we all remember Greta Thunberg and her very impassioned UN speech she made a few years ago. Alexandria Ocasio-Cortez, an elected United States official, saying that we've got 12 years till the end of the world. I received an email from a presidential candidate today, and I wanted to share with you the first sentence of this email. I want you to hear, well, even the subject line. Here's the subject line. "Our leaders are burning the planet." That's the subject line. First sentence: "As we continue burning fossils and bringing our climate closer to apocalypse, the COP 28 climate conference is taking place in Dubai." Apocalypse. Now, I'm a scientist. I'm a geologist. I am probably much closer to the science of what's happening under our feet in our atmosphere than any of these people, with the exception of the leader of that climate conference, than any of our politicians. Our politicians, and I'm not going to say these are bad people. One of two things is happening. They either have not taken the time to explore and understand the issues that they are basing their policies upon, and that they're asking us to support them in the policy decisions upon. Either they haven't taken the time to understand it, or they do, and they are part of the problem. They are working against the very foundational principles that can help us to free our society, to lift people out of poverty, and to create the innovations in the world that we know are possible. One of those two things is happening. So this is really, really interesting to me. We're being asked through the United Nations, the World Economic Forum, different branches of the World Economic Forum. You watch the political debates on both sides. I'm not taking sides on this, because they're both doing exactly the same thing in the United States of America. Both conservatives and the liberals, both red and blue, they are both basing their information and what they're saying to us very impassioned. There's no doubt that they're impassioned. And I think there's no doubt that they believe what it is they're telling us to be true. The problem is the science doesn't support it. And we are on the verge of destroying a global economy and creating a tremendous amount of suffering in the demographics of people that have the least bandwidth to absorb the kind of changes that we're being asked to make. Now, I don't want to be, again, redundant, because I've addressed this in previous videos, and I'm going to reference those. But what I'd like to do, let me share with you, and I'll put a little visual presentation together. I'm going to do two things. Let me share with you where the information is coming from, what it's based upon that is driving this hysteria. And by the way, the hysteria is shredding our families, our communities, our society, and our nation. We're deeply divided over the misinformation and the disinformation that is being shared here. So I want to talk to you about where that information is coming from, number one. Number two, I wouldn't begin to assume that if you're seeing this, you have already seen everything I've already done. I know you're busy. It's a big world out there, and there's a lot of information to consume. So after I share with you where this information is coming from, number one. Number two, I will do a really brief encapsulation, a summary. Some of those previous videos that show, number one, the temperatures that we have right now are not the warmest the Earth has ever been. Number two, we don't have the highest CO2 levels that we've ever had. Number three, high CO2 levels and temperature are not necessarily related. That's a shocker to some people. I think that was number three. Number four, that high CO2 levels have actually been really good for our planet in the past, and that the goals that are being presented through the World Economic Forum, through the United Nations, if we were to achieve those goals, it's not a world you would want to live in. It's not a world I would want to live in. It's not a world that is conducive to life. So I will do that briefly as we go through this presentation as well. So let's jump into just the information. And what I'm finding is a lot of people in our genre are not aware of what I'm going to say to you. They don't have this information. They've never seen this information. They just hear the narrative repeated again and again and again. I did a video a couple of weeks ago on fifth generational warfare, 5Gen warfare. We're in 5Gen warfare right now. There's a battle for our planet. There's a battle for our nations. There's a battle for our humanness. And I've covered all of that in previous videos. Fifth generational warfare is the warfare that begins in the mind before anything kinetic ever begins. It begins in the mind. It begins in our beliefs. And it begins with an information war to soften the battlefield before the policies come in and before the laws are enacted. Because once that fifth generational warfare has exacted the damage that it is doing, and it is very effective, then it makes it much easier to push these policies. So when we hear our politicians, again, I'm not going to say these are bad people. They are they are the consequence of this fifth generational warfare. They are casualties of this fifth generational warfare because they have heard, and you have heard, the misinformation, the disinformation, the false cherry-picked data that leads us to a conclusion that simply is not true. And based upon those conclusions, you and I are being asked to change the way we live when it comes to fossil fuels. And if you think this is just about driving your car, I spoke with some young people recently and they said, well, you know, we can use electricity to run our cars. Over 6,000 items in our daily lives, 6,000 aspects of our daily lives are directly linked to fossil fuels. If we truly had something to replace those fossil fuels, that would be a different conversation. We have the potential for other forms of energy that have not been allowed in the public sector. And until that potential is realized, to do away with the fossil fuels is going to create tremendous suffering, tremendous hardships, economic hardships, agricultural hardships, certainly hardships in terms of industry that requires vast amounts of electricity that cannot be created, supported, stored, generated to the degree and in the quantities that we now have access to. So if we're going to do away with what we have, it'd be nice to have something already in place to fall back on. That is not the case right now. So let's jump into this. I want to show you the science, the false science, and scientists know it's false, and you're going to see that as well. Where is this information coming from? Why do some people believe we have 12 years left? Why do they believe that carbon dioxide levels are causing problems in our lives? I think you're going to be surprised at what you see here. So the question is, where does the UN get the information for the climate projections that our media, that our politicians, that our policymakers are basing their hysteria upon, or basing their impassioned speeches upon, and the platforms that they are running for public office upon? Where's that information come from? Well, they come from models that are made on computers, all right? If you're going to project what's happening in the future, you need a way to take information based upon the past and the present and to weave that into something that can reasonably tell you what you can expect to happen in the future. These are called computer models. Now, I'm probably closer to computer modeling than a lot of people because I did computer modeling when I was in college at Colorado State University. I worked in the remote sensing lab where we used thermal information, optical information, and historical information to build computer models of forests during the Cold War years, so that when our satellites were looking at similar forests, the same kinds of trees, the same elevation, same climate in Russia, for example, or in East Germany, if there were implements of war, if there were tanks or missiles that were hiding in those forests, they would show up as anomalies in the models. So I had the opportunity to work on modeling, certainly nothing anywhere near as sophisticated as what's happening now. So, but I do understand the modeling system. You have to build a mathematic model of the systems to have those projections. So climate models. When we look at the Earth, the way that climate scientists are building these models, if you look on your screen, there is the Earth, and the entire planet is divided into grids, cubic grid sections like you're seeing on your screen right now. And every one of those grids has a mathematic formula that represents what's happening in that grid, everything from the ocean and under the ocean to the surface of the ocean, to the humidity, to the temperatures, to the cloud cover, what's called solar radiance, all of those kinds of things. And there are many different models that have been built beginning in 1995. They're called CMIP or CMIP climate models. CMIP is an abbreviation for Coupled Model Intercomparison Project. So we're going to begin looking at charts based on CMIP. So you will see multiple climate models. So they're taking different parameters, and you'll see them all projected onto the same graph and where it is that those parameters are leading us. So here's what I mean by this. When we divide the planet into these into this grid, and each grid has a very precise, and this is both for vertical kinds of information, what are called vertical exchange vectors between high altitude, low altitude, and all of those things, and horizontal. I mean, wind currents, all of these things are taken into account. And there's a sample, there's a mathematic formula so that mathematically what's happening in that one grid, in that one little piece, is being represented. And then they take all of those mathematic formulas representing all of those grids, and they put them together to create a projection. Now, as you can imagine, this takes a lot of computing power. Some of the biggest computers in the world are using this. So I have no problem with the principle of modeling. Where I do have a problem is that the models are deeply, deeply flawed. The scientific community knows this, and we are so far down the road in this narrative that it's very difficult to push back. It's very difficult to share the truth of what's happening. Scientists, their tenure depends upon this at the university. University funding depends upon this. If you're a researcher, your research has to support these models. There's all kinds of conversation about the levels of corruptness that are happening behind the scenes building these climate models. All right, and let me just show you what's happening. The first assessment report, called FAR, a very innovative acronym. The second assessment report by the UN, SAR. The third, TAR. And the fourth, they changed the notation a little bit, assessment report 4, AR4. What you can see on your screen is that the information in each of those little cells of the grid is becoming more and more refined, or what we say is there's a higher resolution of information. So we're getting better at refining the data, but the principle the data is based upon is what's flawed. So I want you to take a look at this. This is an example of CMIP. So they are called representative concentration pathways, RCP. What you're seeing on your screen, each of those little squiggly lines is one model that is modeling some aspect of, Earth's climate system, where parameters have been adjusted or shifted or changed one way or another. And you can see that the models are all over the place, but they are generally trending to the top and to the right. So in the future, if you look at the bottom of your screen, the year 2100 is on the right-hand side of the screen. 2080, 2060, 2040, 2020 is where this begins. So they're all over the place, and in general, they are trending up, which is warmer as we go right to our future. So this is an example of IPC climate models of representative concentration pathways, RCP, and you can see they're color coded. The RCP colors in the upper left-hand part of the chart represent the little squiggly lines that you're seeing. Now, the next image that you're going to see is where these predicted models are compared to the actual data. If a model is a good model, here's what should happen. If it's a good model, if it represents all of the parameters accurately, then you should be able to take that model after a moment in time has already occurred. So after the year 2020, for example, has already occurred. And you should be able to go back in, because now we know what the temperatures were, we know what the humidities were, we know what the reflective properties of the clouds were, temperatures in the ocean, we know. So we should be able to plug those in to the model. And the model, if it's a good model, it should tell us exactly what happened, because it's already happened. It should overlay it perfectly. Check this out. This next image is the predicted model versus the actual data. What you're seeing in the black for at this period of time is the actual what would actually happen. This is compared to all the predictive models. And what you can see is what actually happened is nowhere near what was predicted in that period of time. Look at it's on the low end of that channel. And the term that's used at these models are actually running hot. All right, hot in terms of literally in terms of temperature. So there was a committee, United States House Committee on Science, Space, and Technology hearing. March 29, 2017 is when this happened. So this is how long ago we knew these models were flawed. And I'm going to share with you one part of the testimony. This is John R. Christie's professor of atmospheric science. So he knows what's going on. Alabama State climatologist, University of Alabama. These next couple of charts are from his testimony in the United States U.S. House Committee on Science, Space, and Technology. Here's what's happening. There's a lot going on here, but you now have enough. I think you're going to be able to see what's going on. The upper part of this graph are the CMIPs. These are all of the climate models. You can see, again, they're all over the place, but they trend warm and into the future. The red line is the average. So they took the average of all of those models and said, okay, some models are high, some are low, but in general, what are they saying? They took that average of 102 of those models, and you can see that red line represents the average of the models. Now, below, what Dr. Christie did was he and his team took real-time data. They used balloons into the atmosphere to sample the atmosphere, to actually sample the atmosphere. They used satellite imagery and satellite information to actually sample real-time what was happening. And when they plotted the real-time data against the predictions, this is what you're seeing on the screen. And what you're seeing below from Christie, you're seeing those three. The circles are balloons, the squares are satellites, and the diamonds represent a little bit different kind of analysis that I won't go into here, but they're all real-time data, all right? And it's obviously what's happening. The predictions are way high and way hot, and the actual data is nowhere near those predictions, all right? So this is one example, but this was congressional testimony. There are other examples of this. Now, if this looks on your screen, if that looks too complicated, here was a simplified average that Christie did as part of that testimony. The red is the average of those 102. And then down below that, you're seeing the blue and the green, and I don't know if you call that a plum or purple or whatever it is. You can see the same thing. The real data is far below what the predictions were to be. Here's another image. This is also from Christie, from another part of the testimony. Look at what's happened. There's 68 models, CMIPs, that you're seeing from the year 1979 all the way up to 2020. And you can see they're all over the place, but they are all trending warm to the future. The black line that you're seeing, that heavy dark line, is the real-time data. Not only are those models running hot, but the real-time data is showing us that there's a cooling that's happening that the models don't account for. Now, why are we having the problems with the models? Well, what I'm going to say to you as a scientist, as someone who has experienced computer modeling in the past, again, it's not that the principle is bad. I believe we can model our atmosphere. The problem is, and the earth and the oceans, the problem is that this is a dynamic that is so poorly understood that the models are incomplete. The models can only represent what we understand about the earth and our relationship to the earth. And there is so much more. There are so many spheres that we all know. There's the atmosphere. Well, there is the hydrosphere, the oceans. There's the lithosphere. That is the land. There's the cryosphere. And there's an interplay between all of these different spheres that is so poorly understood that it cannot be modeled in a way that can even tell us what has happened after it's already happened. Yet, this is the information that you and I are being asked to use, to trust, to change the way we live, to destroy our economy, to destroy a global economy, to destroy jobs, to prevent nations from achieving in their experience the benefits that we have achieved in ours. It is because of fossil fuels that we have lifted ourselves out of tremendous poverty. We use energy 6,000 places in our lives every day. It's just not about driving cars. This isn't just about airplanes. And most people don't even think about how that energy is used. Number one, then the people I talk to that say, oh, well, we will replace that with solar and wind and batteries. I've got an entire video on this, and we'll put the link below. What I'll say right now is, first of all, the 17 rare earth minerals that are required for all of our technology, solar panels, batteries, windmills, computers, cell phones, all of that. They're all based upon 17 rare earth minerals, and they are just that. They are not common in the Earth's crust. They are in essentially 2 to 3 large deposits. 2 of those are in nations that aren't our best friends, in China and Russia. And they are finite deposits. They are toxic to mine. In the case of cobalt used for the batteries coming out of DRC, Democratic Republic of China. The mining is happening through unregulated child labor, little kids barefoot standing knee deep in the water in these earthen mines. They're actually holes in the ground, digging through the mud with their bare hands for the ore that they put into a little pouch they wear around their waist. Then they send that to the adults. The adults aren't down there in that muck, it's the kids. To the adults on top, the adults that take this, they clean it up, they send it to China. China refines it, makes it into the materials that we need, and they sell it to us for batteries for our electric vehicles so that we feel, this is the virtue signaling, we feel that we're doing something good for the environment. The fossil fuel imprint that is required to refine and mine those rare earth minerals offsets the benefit by magnitudes, number one. Number two, they're toxic materials. Number three, at the end of their life cycle, what we're finding right now, solar panels showing up and batteries showing up in the landfills, those toxic materials are now seeping into the groundwater, into agricultural water, into rivers and streams, and people's homes and people's drinking water. Now, can we do something about that? Absolutely. The point is, we're not right now. And even the silicon itself, a lot of people believe that silicon just grows in the ground and you make a computer chip out of it. It takes very high heat to create a silicon chip, higher heat than can be accomplished through a solar panel or through a windmill. This takes fossil fuels to do that. So what I'm saying is, what we're being told is a solution. And I love solar panels. I've got 19 solar panels running the building and the studio where I am right now, where it makes sense. Geographically, where it makes sense. I love the idea. And I love the idea of electric vehicles where it makes sense. It's not one size fits all. We cannot place the future well-being of a global population on finite resources that are toxic on the beginning of their life cycle, toxic on the back end of the life cycle. They're expensive, they're not reliable, and they're not going to hold up through the climate changes that we're seeing right now. So I'm saying that because we're being asked to make those changes based on models like you're seeing on the screen right now that are it's not like they're off a little bit. They're predicting the apocalypse that I received through my email that AOC and Greta Thunberg are talking about. Those people are basing their passion upon the information of people they trust. That information, I used to say it was misinformation, disinformation, but now that we know it's true and we're still propagating information, you've got to call it a lie. This is a lie. It is a climate lie. All right. So let me tell you what Christie said in the paper regarding his findings at the House committee meeting or hearings. He said, quote, "The consensus of the models fails the test to match the real world observations by a significant margin." Okay, that's what we just said. The actual data fails to match what was predicted, and it's not by just a little bit. He goes on to say, as such, because this is happening, the average of the models is considered to be untruthful in representing the recent decades of climate variation and change, and thus would be inappropriate for use in predicting future changes in the climate or for related policy decisions. Now let that sink in. This isn't conspiracy. This isn't politically based. Here is a climate scientist telling you the data doesn't support the narrative. He's saying it'd be untruthful to represent what we've seen in those models, and that the models are inappropriate for use in predicting future changes, either in the climate or for the policy decisions. So here it is. How come we don't hear about this? This is part of the fifth generational warfare that I spoke about in another video. It's the warfare that begins in the mind and with our beliefs before it ever reaches the place where something kinetic is happening. There's a battle, many battles playing out. There's a battle for our body. There's a battle for our health. There's a battle for our beliefs, a battle for our thoughts. There's a battle for Earth. There's a battle for our divinity. And I talk about all of these in the videos that we have on this channel. That battle right now is being waged in our minds and in our hearts, what we believe to be true. And you're seeing this reflected in people all around us. And I wanted you to see, number one, because the climate change conferences are happening now. COP28 is happening now. Number two, we're going to have a year of people, of politicians, some of them we may like more than others when it comes to climate, if they are telling you that we've got 12 years left, if they're telling you that we have to ban fossil fuels, what you know is they're either misinformed, they haven't taken the time to understand the policies that they're asking you to accept, or number two, they do understand it and they are part of something even more nefarious that I'll talk about in another video. One of those two things is happening. They're not alone. John Christie's not alone. Look at this. Dr. Judith Curry, she's a former chair of Earth and Atmospheric Sciences at Georgia Institute of Technology. This is a very prestigious university. Here's a link. You can see her entire statement. What she says is there is no climate emergency. We're being told that we've got to, the hysteria is just off the charts. Freeman Dyson, a physicist, British-American theoretical physicist, very well known for in terms of the Nobel laureate and the principles that he's worked on. He says, I don't think there is any catastrophe. It's foolish to do anything spectacular, which is what we're being asked to do, to change an entire model of civilization in response to climate change. Now, nobody is discounting the fact that the climate is changing. And that's the point. As a geologist, I've been talking about climate change since 1979. It's my first year in the industry in Denver, Colorado, when I began working in the energy industry. Very well-known fact. Geologists know this. Climate change is a fact. Disingenuously, we're being told if we fight against it, that somehow we're going to change what's happening rather than adapting to the climate change. And I'm going to talk to you about where it's coming from here in just a moment. Adapting to it's only a problem if we're not prepared for the change. It's only a problem if we choose to live our lives and build our homes 10 feet from the edge of the ocean and have our vital power lines on spindly little sticks, the telephone poles that are vulnerable to high winds and to ice storms that come with climate change. It's only a problem if we continue to live the way we've always lived. We can adapt and prepare for and harden our power grids and do the things that are necessary to minimize the impact. And we're not doing that. We're being told falsely that all we have to do is give up an entire industry, way of life, and economy and somehow everything's going to be okay. The evidence doesn't support it, just doesn't support it. All right, so I began, where's the information come from? I just gave you a couple of examples. The IPCC models are based upon computer models. Most of these are developed in the academic world. Good scientists, they just don't have all the information. We do not understand this, and I'm going to go into some information now and show you what it is we don't understand. So where's the information come from? I just covered that. It's all based, now think about this whole conversation, this whole COP28, the whole World Economic Forum push, the whole United Nations 17 Sustainable Development Goals, it's all based and predicated on the belief that carbon dioxide is bad. Number one, that it's bad for us. Number two, that an increase in carbon dioxide is a problem for us. Now, I've addressed this in so much detail. I don't want to be redundant. If you've already seen it, you can drop off right now. I don't want you to be bored with the information if you haven't seen it. And I know that not everyone has seen, again, every one of my videos. Let me just summarize it really quickly for you here. Just a couple of slides from previous presentations. Number one, we're being told that we've got the highest levels of CO2 that we've ever had. The fossil records, the ice core records simply don't support that. And what you're seeing is an example of that right here. On the right-hand side of your screen is present day. Left-hand side of your screen is going back 400 million years. The black line is the CO2 levels. The red line is the 2021 CO2 level. This is what they're using as a baseline, about 417 parts per million. So look at how much time in Earth's past we have been over for 417 parts per million. Arguably, most of the last 400 million years, we've been over where we are right now. We've been over that. Humans only emerged where you see that green line. I'm using a red arrow to point to the green line. That's where humans emerged. I'm going to do this another way. These are from the ice cores in Antarctica. This is temperature versus CO2. Red's temperature, blue is CO2. And again, present is on the right-hand side. All right. That green line is when humankind emerged about 200,000 years ago. Scientists are in total agreement with that date. Yes, anatomically modern humans emerged 200,000 years ago. So look to the left of when we emerged, and you see carbon dioxide levels ebbing and flowing, rising and falling before we ever got here, just like they are after we got here. But you also see something that is really, really difficult. It's an inconvenient chart, is what many people call this. If you're moving from the left to the right, if you're moving from 800,000 years ago to the present day, look at what rises first. It is the temperature rises before the greenhouse gas, before the carbon dioxide. The blue, by the way, is CO2. That's a problem because we're being told it's the rise in CO2 that drives the temperature up. Well, here you're seeing the temperature rise before that CO2 ever rises. You're seeing it before humans emerge, and you're seeing it after humans emerge. There is a reason for this, and it's something that a lot of scientists simply don't want to talk about. All right. So what are we saying? Is there a direct link between CO2 and temperature? There may be, but it is not an absolute. Here's a chart. The right-hand side is present day, left-hand side 600 million years before present. The black line is the CO2. The blue is the average temperature. And look at what's happening. Look at between 100 and 200,000. Look at the bottom of your screen. You see 100, and then you go left 200. Midway is 150 million years ago. Look at what happened. The black, the CO2 was high, but the temperature is low. All right. If high CO2 drives high temperatures, that's not supported there. And then you see it in other places as well. Or you see the temperatures are high, but the CO2 levels are low, where you see 100 million years all the way up to the present. Look at where the CO2 levels are. Look at that black line. From 150 million years ago to today, it declines to the right. It goes down to the right, we are at historic low levels of CO2 in terms of Earth history. Now, are we higher than we were 10 years ago? Yes. Are we higher than we were 20 years ago? Yes, we are. Is that a bad thing? Well, if we go back and look at history, it doesn't look to be a bad thing, because Earth not only survived, Earth thrived. I'm going to show you that in those high levels of CO2. But again, what you're seeing here is that the CO2 levels that we have today, even though they're higher than they were 10 years, 20 years ago, they are nowhere near. We are on the low end of where carbon dioxide is historically on our planet. Now, what is driving the CO2? Here's a mind blower. I did an entire presentation on this. Check the link below in the comment section, and you can see the entire video. I've got it up here, absolutely no charge. Scientists have recently discovered there are processes underneath our feet, between the core and the mantle and the crust of the planet, that are driving climate change. All right, that does not fit the narrative. It's not what our presidential candidates want to talk about. It's not what high tech wants you to know. It's not what the World Economic Forum wants you to know. It's not what the United Nations wants you to know. It's what's happening. All right. And I do an entire video in much detail. I'm just going to highlight right now. The bottom line is that there are changes in the core that are driving changes in the mantle. The mantle is a hot, molten material. There are places where it is being forced into the crust, as it does on a cyclic basis, about every 13,000 years, 12 to 13,000 years. And there are reasons for that. As that warm magma is coming up near the surface under the crust, it is, and here's a beautiful model. What you're seeing right now on the right-hand side, these are called mantle plumes. These are computer models. They're computer imaging, modeling where this magma is coming from the mantle in a couple of places on Earth, and then it spreads and it's warming the Earth, it's warming the oceans. There it is right there. So what you see is it is happening under the Pacific Ocean, and it's happening under parts of Africa and into the Middle East. You would expect to see increased seismic activity where these things are happening, and that's exactly what you're seeing. Syria, Turkey, Pakistan, India, but you're also seeing it in the Pacific Ring of Fire. You're seeing it in the islands, all right, in the Pacific. So what is the implication, the climate implication? Now, I want you to look at the bottom of your screen. This isn't my theory. This isn't a conspiracy. Look at the bottom of the screen. This is climate.nasa.gov. NASA knows what I'm saying to you. Here's the quote: 90% of global warming is occurring in the ocean, causing the water's internal heat to increase since modern record keeping began in 1955. All right. What's the big deal? What does that mean? If you remember your high school physics, cold water holds more gas. Carbon dioxide is a gas. The oceans of our planet are the biggest. It's called a sink, a carbon dioxide sink, S-I-N-K, or a sponge or an absorber of carbon dioxide. And they continue to. The oceans are absorbing a lot of carbon dioxide, as are the forests. That's going to be important in a minute. When the oceans are cooler, they hold more carbon dioxide. When the oceans warm, guess what happens? They will hold less gas. Where does that gas go? It's emitted into the atmosphere. It's exactly what's happened. About 340 gigatons of CO2 annually are coming from the ocean, as opposed to 35 to maybe 40 gigatons from industry. All right, so the oceans are where most of the CO2 is coming from. The oceans are warming, but look at this. They're warming from the bottom up. Glaciers are melting from the bottom up. They're melting from underneath. That would not be the case if the warming was from the atmosphere. I'm not saying to you anything that scientists don't already know. These scientists just don't have a platform, and they are beholden, in many cases, in academics, they're beholden to funding sources, and they can't talk about stuff like this. So this is NASA telling us 90%. Yeah, are we contributing a little bit? But it's not causing the climate change. We are not the sole source of CO2. We're not the sole source of greenhouse gases. That is a statement that was made by one of the participants at the COP28 in a television interview. He said, we are the source of the greenhouse gases. Not true. Fossil fuels, he said, are the source. Not true. All right, so this is where this is coming from. Now, I'm just going to do this again. I'm going to do this very quickly. Is carbon dioxide bad for us? Well, let's take a look at the past. Whoops, going backwards. Triassic period in geologic history is a very specific mark in time. Carbon dioxide was high, 2,000 parts per million. Right now, it's only 417 parts per million. Earth didn't die. Forests were green. It was warm on Earth. How warm? Between 122 and 140 degrees Fahrenheit was the global temperature. These are like Dubai temperatures as a global average. Uncomfortable for some people, but certainly not the end of the world. Now look at this. Jurassic period, now we've all heard of this because of the movies, CO2 dropped to 1,000 parts per million. And again, we're at 417. 1,000 parts per million, the average global temperature, not bad, 80 degrees, 80.6, 81 degrees during a day, 59 degrees at night. Those are nice temperatures. With 1,000 parts per million, much more than we've got right now. But then look at this. During the Cretaceous period, CO2 jumped back up to 2,000 parts per million. It didn't drive the temperatures up. Look at this. Global average temperatures, 82 degrees Fahrenheit. It's actually 2 degrees warmer, and 52 degrees Fahrenheit at night. There is not a direct correlation between carbon dioxide and temperatures. There are other factors, and those factors are not incorporated into the climate models that are being used right now. By the way, where you see in the Jurassic and Cretaceous, those higher levels of carbon dioxide, the forests were deep, dense, green, abundant sea life, abundant land life. This is the diversity of life that was thriving because CO2 is food for the plants. It's food for the forests. Now, United Nations World Economic Forum, they have given us very specific targets. Now, I'm speaking quickly because this is a summary. It's in more detail in the other videos. They're giving us targets they want to meet. 2021 carbon dioxide level is 414.7 parts per million. The United Nations is using the year 2010 as the baseline, all right, at 390 parts per million. All right, and what the UN wants to do, the goal is a 45% reduction from 2010 levels, all right? 2010, 390 parts per million. 45% reduction in that would be 214.5 parts per million. If that sounds low to you, you're right on. That is dangerously low. You don't want our planet to drop to 214.5 parts per million. Let me show you why. This is from a peer-reviewed paper published in the journal Nature. This is Nature Communications, 2019, so it's fairly recent. If we were to reach those climate goals, when was the last time we saw them on planet Earth? It was during a time called the Pleistocene epoch. All right. This is a direct quote from that paper. The study shows that for the entire Pleistocene era, CO2 concentrations averaged 250 parts per million. They averaged 250. Look at this. The UN wants us to go all the way down to 214. Well, what was Earth like at 250 parts per million during the Pleistocene? Well, check this out. The average CO2, the average temperature, the average ice, and what it did to life. During the Pleistocene, the average 250 parts per million. Today, it's 417 parts per million. The average temperature was 46 degrees Fahrenheit. Today, it's 57. So the average global temperature would cool by 11 degrees. The ice coverage, this is a big deal for agriculture, for when we plant, when we harvest, when seasons begin, when seasons end, when the rain happens, when the rain stops, when the snows come, when the snows stop. The ice coverage during the Pleistocene, look at this, 8% of the Earth and 25% of all the land were covered in ice, primarily Northern Europe, North America, certainly up through Canada. Today, we're nowhere near that. Only 3% of the Earth and only 11% of the land is covered in ice. Do you want to go back where the global temperature is 46 degrees average, where 25% of our land is covered in ice. And look at this, during the Pleistocene, there was a loss of forests. Forests died because the food for the forest, the CO2 was low, and the ice covered the forest. The forest couldn't live under the ice. There was an extinction of large mammals. At least 32 species died over the course of a couple of thousand years. What's NASA saying right now, in the little bit of warming that we've had, the little warming and the little bump in CO2 that we've had in the last 20 years, NASA says Earth is now greener now than it was 20 years ago. Earth's forests are thriving. And this is important because the forests are absorbing excess carbon dioxide that is produced through volcanoes, through natural events, as well as through human industry. We need those forests. If we go back to 46 degrees Fahrenheit, average temperature, 25% of the landmass covered in ice, we lose forests, we lose the ability to absorb that CO2. I'm not even talking about the sun and the solar minimum. I'm not even talking about the Milankovitch cycles that play into this, all contributing to these shifts in the climate. So if we were to meet those UN, United Nations, World Economic Forum goals, we would see an Earth like we have not seen since the Pleistocene. So now you got to ask the question, who benefits from that? Who benefits from a planet that has less forest, is colder, has fewer forms of life, and it's going to impact human life, human migration? We're going to lose people. Who benefits from a lower human population and a lower animal population, a colder climate with fewer forests? The answer to that question is beyond the scope of what I can do. Well, in this, I wanted this to be concise. I wanted you to see where the UN data is coming from, but I'll give you the answer in a nutshell. It's not us. This isn't good for us. We don't benefit from this. And you have to ask yourself, who does? That is a conversation for an entire video. The climate hysteria that we're seeing right now, who benefits from that? The well-intentioned people that are perpetuating what we now have to call lies. We have to call them lies because the data is there. The scientific community knows that the models are running hot, and yet they are still attempting to collapse an entire industry based on fossil fuels that are arguably contributing to higher levels of CO2. If you think that's a problem, then you have to ask, why have we not brought forward the technologies that we've had for over 70 years that the industries today simply don't want on the market because they can't compete with it? There's an economic principle going on here. This also ties into what is being called disclosure. You know, disclosure, we've talked about in other videos, a lot of people are talking about the disclosure of our relationship to life beyond this world. If we have vehicles that have come from somewhere else, either another planet or in a future time, that are traveling back in time, if we have that, and we're being told we do, and if we have the beings inside those vehicles, and we're being told that we do, then we also have to have something else. Those vehicles didn't get here on a Ford V8 internal combustion engine. They didn't get here on what was powering your dad's Chevy Camaro, you know, those eight cylinders. They are moving on a form of energy that not only is a form of propulsion, but is a source of energy that could revolutionize our planet. Not just revolutionize, but free humankind from the bondage and the shackles of the tyranny that has come from a finite source of energy that we've been using for 150 years. All right. If we want to phase out those fossil fuels, if we really want that, and I'm not sure that we do, I think we can keep those fossil fuels and incorporate the new forms of energy as well, and have them very harmoniously giving us options, because one size can't fit all. One size can't fit all on a planet as geographically as diverse, as climatologically as diverse, as ethnically as diverse. We have different needs, different dreams, different goals, different desires, different ways of living, and there's room for all of it without the hysteria of frightening people and keeping people in fear. So once again, we have to ask ourselves the question, the choices we're making, are we making the choices based on the love of what we know is possible in our lives, or have we succumbed to the fear of what happens if we don't make those choices? There's a fifth generational warfare that's being directed at you and me so that we do the former, so that we make our choices based upon the fear that is being perpetuated through climate science that simply is not supported by the data. All right, I'm going to stop here. I hope this has been useful for you. As usual, drop me a note. I'm assuming they will leave, the company will leave the comment section on. You're going to see a little pop-up from YouTube informing us of what climate change is, because the algorithm is going to pick up the word climate change. You'll see a little window come up and it's going to tell you what climate change is. Read what it says and ask yourself how that compares to what you've seen through the science that I've shared with you. And we'll take it from there. All right. Thank you for sharing part of your day with me today. I look forward to our next.